Hello and welcome to the show. It's me, JP, and it's time once again for JP's product pick of the week. Here we are. Are you ready? I'm ready. Let's pop that little thing on there and get ready to head on over to the product page for this week's product pick if you want to get a huge discount on a tremendous little gizmo. So what I'm going to do is send you there. Head over to, I can't be wrong if I point that way. Head on over to that QR code right there or this URL. It's adafruit.com/product/4648. And that is going to take you right here to this very product page where, if I refresh right now, you're going to see that we have this on sale for 50% off, which is tremendous. So what I'm going to do right now, in fact, let's jump back here. So if you have a chance, go there. And you can watch the video from inside the product page. That way you'll know what's going on and you'll be surrounded by product. So buy some, right? That's what keeps the lights on here at Adafruit Industries. We appreciate it. But I'm jumping the gun. What is this thing anyway? Well, what I'm going to do is I'm going to start off and have Lady Ada explain it to us in her new video. Then I'm going to grab one out of my cabinet of mysteries and wonders back there. You can see that right there. And then I'm going to do a little demo and talk about it. So please take it away, Lady Ada.
The PCF8591, it's a quad ADC and a DAC. It's a very interesting chip. Not exactly sure what this was designed for. Probably like a car radio though, because every time I'm like, what is this for? It's always like a radio, playback system for cars or something. But you get 4 analog inputs, 8-bit, and 1 analog output, which is unusual. Usually you don't get both. And it's all controlled over I2C. It's a really simple chip. We've got Python and Arduino code. And this would be really handy, I think. I have the demo here with a Feather, but I think it actually would be really great for use with, again, single board computers like a Raspberry Pi or a Jetson or a Coral or any of these other Linux boards that have I2C, and you just want to add some like potentiometers or like simple analog sensors, and you don't want to get like a more expensive ADC, and maybe you want a DAC for some reason, you want to like control a gauge or a bias voltage. It's only 8 bits, but really that's good enough for many projects, like volume control or contrast control or whatever. So here I've got 3 potentiometers, and as I twist them, you can see they range from 0 all the way to the end to 255. So those are the 3 inputs, and of course there's one more input I don't have connected. And it comes in a STEMMA QT format, so you can just plug it in. You can plug it into that quick Pi hat we showed earlier, and works from 3 to 5 volts. So it's a great way to just add, very simple ADC inputs to your I2C capable board.
All right, well, I want to check it out. Hang on one second. Let me go grab one out of the cabinet. Be right back. Woo, all right, well, that was risky, but here I am. I'm back. I made it. Thanks, Lars. So what we've got this week, it is the PCF8591, and it is an 8-bit ADC and 8-bit DAC on a board with STEMMA QT. So what's this good for? Why do we want this? Well, a lot of the times when you're doing microcontroller projects or particularly single board computer projects, you'd like some simple input from a fader or a knob, so a slide potentiometer or a rotary potentiometer, is that what we call them? Angular potentiometer? Or other things like touch interfaces, some of those soft pots, things like that. And you don't always get that many analog inputs on a microcontroller. Sometimes it's limited to 2 or 3 if it's a smaller board with fewer of the pins broken out. And one thing you've probably noticed if you've done any work on Raspberry Pi projects is you generally have 0 analog inputs. There's a lot of GPIO for digital inputs and outputs, but you don't have any analog. So here's what you do. You plug this in. So this board here has the STEMMA QT breakout on it. So it's the SparkFun Quick Compatible I2C little itty bitty connector that we can use to plug that in to your Raspberry Pi. Now you can either do that with a sort of breakout cable, or what I'm going to show you here, I'm going to switch to my down shooter, and what you'll see is that I have a Cyber Deck. You can see the front there, it says Cyber Deck. I've got a Cyber Deck plugged into the GPIO pins of this Raspberry Pi 400. So this Raspberry Pi has its normal breakouts there. I can't move it too well without probably breaking everything. But those breakouts are a little hard to get to, so we have this new Cyber Deck product, and actually I'll show you a product page for that in a minute. That gives us the ability to plug in any of the normal Pi hats or bonnets at a jaunty 30-degree angle. It can really only be described as jaunty, I promise you. I've tried other things and it doesn't work, you can't say it. This also gives us a couple of STEMMA QT breakouts and STEMMA breakouts, which are the 3-pin larger JST PH, so that we can plug in things like NeoPixel strips or other 3-wire devices. And what I've done here is I've plugged this over I2C into our PCF8591. Now what I have running into this board are 4 potentiometers, so I'm using the ground, the voltage, and then 4 separate analog input pins. And then I've made a little demo here. So what you'll see, this should be still running. Let's see if my plotter is running. Yes, it is. Okay. So you can see here what I've set up on screen is this Raspberry Pi is running a little Python program that uses the CircuitPython library for this board. So it's dead simple. I'll show you the code in a second. And it reads all 4 of the analog inputs. It's essentially reading 0 to 255. So these are 8-bit ADCs. They're not super high resolution, but for a lot of the things I want to use them for, such as synthesizers and MIDI, that's great. That's enough resolution. That's actually double the resolution that MIDI CC usually uses. And you can see here, I've got it controlling the hue of these NeoPixels, or RGB LEDs, on this very cool Unicorn Hat HD from Pimoroni that I've got plugged in. You can see here it's got a cute little diffuser on there. Those are the raw pixels. And I've decided to use all of these knobs, because why not? They're here. So what I'm doing is tracking the first knob here. I'm calling it knob 0 for the X position. And you can see on my, let me angle this up a little. You can see on Mu here, I'm using the plotter right inside of Mu. This is running on the Raspberry Pi. And now I can control the vertical pixel line here with this second knob. Third one we saw, that's changing the hue. Just sweeping through all of the hue angles. And then the last one is brightness. So you'll find I can get that pretty zorching bright there, or drop it down way, way low, or all the way off. And as I do this, you'll see this is spitting out these values here. Some of them I've sort of flipped and normalized into ranges like -1 to +1, or 0 to 255, whatever makes sense for, in this case, 0 to 15, which is the number of rows that I have and columns. So let's take a look. How does this work? I'm going to switch back over now to Atom. This is the code that's running on the Raspberry Pi 400. It's not running on a microcontroller because I'm not using a microcontroller. Let's take a look. Let me jump down there so we can still see that, because I think that's lovely looking. And what I'm doing in Atom here, you can see, I'm importing the time library so that we can do delays if we need to. Board, which gives us the GPIO pin layout and I2C and all that good stuff that's on the Raspberry Pi. And then the Unicorn Hat HD library from Pimoroni. I set up the Pimoroni board to light up, set its rotation, because you can change what's considered sort of up and down and left and right. And then I'm importing this PCF8591 library, giving it the name PCF, make it easy to work with. And it is being set up as a analog in on I2C. There's the board getting set up. This is I2C being set up. And then I have these 4 inputs that I get to use right off of the ADC. So you can see here I'm using the analog ins. There are 4 of them. I'm not using the DAC. There's an analog out, one analog out. you could find a use for that, I'm sure. I just am not in this case, but that might be useful if you have something like a low frequency oscillator or other analog output. It's not going to be super high resolution. And then here's what's going on in the code. It's actually fairly simple. What I do is I assign the raw value read of one of these inputs, the PCF_in2 in this case, to this variable, color raw value. And then I do some manipulations to make that useful the way I'm going to use it. So I'm subtracting it from 1 to kind of reverse it. I actually hooked up my ground and VCC backwards, so all these potentiometers, I kind of had to flip their left and right to be down and up. And then I am dividing that by its top range. This is actually read as a 16-bit internally. The library casts this as 16-bit, even though these are 8-bit. So if you watch them closely, I just realized this morning, you'll see those values, those raw values will jump in chunks of 255 or 256. The setup is the same for the next knob, and then these are being divided by 4096, which gives me 0 through 15, which is how I want to array the pixels and lines. In order to print this on the moo plotter, again, you can see here as I adjust those, you'll see that plotter doing its thing. Change the color on that. There we go. Ooh, yeah, it's a nice blue, a little bright. As you see the values change on that plotter, it's because I have created this print statement which sets them all into this tuple. And that's what the plotter in moo is looking for. Is anything you want to show up on the plotter, you put in a print statement with a couple of parentheses around it, and it will show up. The unicorn hat gets cleared, then I set the range for the pixels to fire off from what's going to be considered the column pixel and the row pixel, and then we set the center pixel to black. I just didn't want that crossing pixel. I just wanted that to be a little black spot there, so that's what this line here does, is just sets it to 0, 0, 0. The brightness is changed anytime we're changing that brightness value. It's just kind of continuously. All this is running so fast on the Raspberry Pi that I don't need to have the code be very efficient. It runs great. And then lastly, once all those things have been set up for a given cycle, Unicorn Hat Show sort of blitz that all to the screen. We take a little pause just so we don't flood things, and then that's it. If there's an error, it will allow me to Control-C out cleanly. So that's why it has this key interrupt, turns off the Unicorn Hat HD. So if I go back full screen, where are you full screen? There you are. There we go. So you can see, oh yeah, Todd in the comments said that he likes the hacker-style monitor. So I had a bare 10-inch HDMI IPS display that I've built this into a few different projects, but it was sitting out. It was in a typewriter case at one point, but I'd pulled it out. So I built this little maker beam, sort of like a skinny little version of 8020. I built this little frame for it and hooked it up to there so that it holds the HDMI controller board, the little control panel there. I strapped some speakers to the sides, and it's nice and small, and it's lightweight. I can kind of stick it where I need to and get it out of the way. So there, if we take a look back at there is our board. I'm going to do a little refocus on this. If you'll bear with me, it's a little better. Can't get it too close. Now it's way out of focus. Hold on. Oh, it was there. There it goes. That's close. So here you can see what I've done. This board has the analog outs as well as the one analog out, the 4 analog ins, VCC, ground on the top. Bottom, these are the I2C pins, which I'm actually not using. I just used it for mechanically soldering this to the board. I'm using this little cable right here for the connection to the board, either the microcontroller or the single board computer that you're using. And then I have these just kind of hand wired. I just used hookup wire and wired that up so all of those are sharing a ground, all those are sharing the voltage, and then they're running to the 4 analog in pins to read. And this is actually some of this cute little perf board that we started selling not too long ago in the Adafruit store. I like the look of it. It's kind of got a nice look. It's clean, no logos on it on this side. It's black, kind of cool looking. And it has M2 holes, so you need some pretty tiny screws if you want to attach that to anything. I just put some through there to act as sort of standoffs. And that's it. Now, one of the neat things about this, I'm going to go ahead and cancel that, stop that from running there. One of the neat things here is that we can unplug this board, and this is portable. This has no microcontroller associated with it. It has no particular single board computer associated with it. It's just I2C over these STEMMA QT connectors. So I can plug that into name your microcontroller if you have something that you want to add 4 analog ins to and that 1 analog out. This is it. This is very simple. You could even do a custom PCB for it if you wanted, but I thought keep it lean. Solder this down. I didn't put a socket on here. I kept this lean by soldering this to the board. I soldered these potentiometers down. So this is a little, hey, I need 4 analog ins. Just grab this. You can make a few of these. You can sort of do this sort of design with a lot of our breakout boards if you like, and it makes it very convenient to prototype stuff. So I can plug that back in, and it's going to restart my Raspberry Pi. It was not happy about me hot plugging that in. Oh, that's a bummer. I wonder if I was shorting it, holding the backside of it. So we'll give that a moment to restart there. We'll see how fast this Raspberry Pi boots, and I will relaunch the program just so you can see how we call that. You can also SSH into the Pi from another device and launch it, but I'm not on the same Wi-Fi with it on this computer, so that's not straightforward. So let's see, when this wakes up, all right, let's run moo. And it even left that open for me. Thanks, Moo. I can open up the plotter here, hit run on our code, and we're up and running again. So really fun. I'm enjoying doing some of this development on the Raspberry Pi. A lot of possibilities there. And I'm also really loving this, this cyber deck for adding this little light show here and giving me the I2C STEMMA QT ports. It actually is what inspired me to build this frame in a sort of cyberpunky way. So there you go. Let's see, before I forget, let me show you again. Here is the QR code that will get you right to that product page, 4648. If you head on over there, you're going to get a lovely 50% off, a maximum of 10 of them. One thing I think Lady Ada mentioned it in her video, and I'll reiterate, you can use the little jumpers on the back of this to pick addresses, I2C addresses, and there are 4 different addresses available, which means that you can hook up to 32, I'm sorry, 8. There are 8 addresses available, so you can hook up to 8 of these. Am I right with that? I think that's right, yeah, and you can have 32 analog inputs and 8 analog outputs all on one machine. You just wire them from board to board with some little short STEMMA QT cables if you want. And now you're adding some serious analog in to a project that could use something tiny. This could be running on a QT Pi or a Pico or a Trinket, whatever you want that has I2C should be able to drive this and read a whole bunch of analog inputs, which is really cool. The product page, let's jump over there for a second. I mentioned this before. This will give you a little bit of info about the board and a convenient add to cart button. But if we click on the Learn Guide link that's on that page, this will take you all through the pinouts of the board, how to use it with Arduino. We have a very convenient Arduino library, how to use it in Python, like I am here, right on this Raspberry Pi single board computer, or in CircuitPython on any of the 100+ CircuitPython compatible microcontrollers out there. And if you take a look through this info, get down to the downloads page, there's a link there that'll take you to the datasheet for this chip. This is the PCF8591 chip. You can read all about it, check out some of the operating supply voltage, how it works, sample rates, what the data structure is on it. You can find out all of those specifications right here on the data sheet. They don't even mention, usually I go here and find out, okay, what do they think this board is for? I think they are real vague and say it gives you 4 analog inputs and 1 output over I2C. Good luck, you decide what you want to use it for. But I like Lady Ada's theory that, yeah, whenever you have a car stereo these days, there's a need for 2 or 4 knobs to control some stuff. And so this type of chip will give you that analog in that you can then run into your digital microcontroller to do the rest. All right, well, hey, any questions in the chat, let me know. Let me pull this. I'm going to pull that board off of there again, and I can show you this up close. Someone mentioned something about the wiring on the board. Let's see. Let me give you that down shooter, and now let me try to refocus. There we go. Yeah, so there's the board. So this is a perf board. It does not have any connections. It's just places to solder stuff, but wiring is up to you. It's not like a breadboard or a perma proto board, so or a strip board. You just decide what you're soldering what to. So that's the diagram. Actually, I put this together first in fritzing. I made a little diagram for myself. I can share that if anyone's interested. And these are some 10K pots with some cute little knobs, grippy little knobs on them that make it look nice and easily identifiable. I say it's easy. There we go. Get that back on there. And there's the chip itself, PCF8591, 8-bit ADC and DAC. So I think that's going to do it for today. Let me know if you have any other questions. Susan says the unicorn hat was exactly what I was looking for the other day. Kept searching for matrix. Now I got it in my cart. Oh, excellent. Yeah, that is a cool little board. There's a few variations on these unicorn hats, and they're nice to work with. There's a lot of example code up on Pymerody that you can use to use it with CircuitPython. So, and probably Arduino as well, but I've just used it on CircuitPython. All right. Well, sorry I didn't have any peanuts, but that's going to do it for today. That is my product pick of the week. It is the PCF8591 8-bit ADC and DAC in STEMMA QT format. And I'll set that on my STEMMA QT board of goodness. This is actually the 28th episode of this show that we've done here. I have 29 things up here because I doubled them up one time and threw the Pi in there, or the Pico rather, in there. And I probably should have thrown the Cyber deck on the wall too, but it's kind of hooked up to something right now, so I can't. But maybe I'll look at that a little closer another time. So I think that's going to do it for today. Thank you all for stopping by. Head on over to this URL to get to this page, and you can get 50% off right now until the end of this show. You can get a limit of 10. So if you have big analog input plans, spend $30.25. Do I have that math right? And get yourself 10 of these boards. Why not? And that will give you tremendous possibilities for adding analog input to your projects. That's going to do it. Thank you so much. I'm John Park. This has been JP's Product Pick of the Week, and I will see you next time.